Hi everyone. Well, thank you very much for staying till the end. I really appreciate it. I'm really happy to be here talking about how to unleash the power of vector mapping in our notebooks. And could you please raise your hand if you're a data scientist or if you're working as a data scientist? Okay, awesome. So you may know that as a data scientist, you usually struggle when you have to change the context where you're working on very often. Context switching, it's a kind of, it means to jump in between one scenario to another, and it is a kind of multitasking that actually decreases productivity. And we wanted to avoid that when we started CARTOframes. So we are going to talk about what is CARTOframes, and also how we wanted to improve the visualizations that we were doing by bringing vector mapping through CARTOVL to our notebooks through CARTOframes. First of all, I really want to thank you, this team, because it wouldn't have been possible with the effort of this team consisting of data scientists, cartographers, designers, and developers. And last year, Andy did a presentation about CARTOframes. This is how it looked like. And what we wanted to do with CARTOframes is to help the data scientists to keep the context where we are working on. So usually, when you had to create a visualization from your data, what you did was to, first of all, download your data, analyze it, and then create a CSV that you have to export, and then import it in, for example, in Builder, and create a visualization from that CSV, and it means that you were changing your context all this time. So CARTOframes is a Python package. We decided to write it in Python because it is a language that is widely used between data scientists. It's very popular, but it also is present in many other areas, and it makes it a language that has also a great community. So it is perfect for this solution. And also, well, CARTOframes is just a part of our stack, and I'm going to show you today how we have combined CARTOframes with other parts of our stack. Jupyter Notebooks. What I'm going to show you today is how to use CARTOframes inside Jupyter Notebooks. These notebooks are now the de facto standard for communicating data analysis. They are very popular, and they support multiple formats. You can draw equations, you can write text in HTML, in Markdown, and it is like the way the data scientists use to share the data, where the results and the visualization. So for this, for showing the visualizations in the web now, there is a growing interest in vector mapping libraries and techniques. A common one is using SVGs, for example, D3 is doing right now, but also WebGL has become really popular nowadays. It is the API for rendering interactive 3D and 2D graphics in any browser that is compatible with WebGL. And it interacts directly with the GPU, so you, at the end, you work with all your data locally. And it's been used by Mapbox.gl, by DeckGL from Uber, and also by 3JS, which is a famous library that interacts directly with WebGL. And for this, we have created our own library, which is called CARTOVL, and was presented also last year. It is a JavaScript library that works with WebGL. It's built on top of Mapbox.gl because we use Mapbox.gl for the base maps mainly. And what we can highlight from this library compared with others is that we have created a powerful API that allows you to write great visualizations with a few lines of code. And we also have a visualization language that is very similar with other styling languages, and we are going to see how can we use it to apply it to our maps. So we have CARTOframes that is part of our stack. We have CARTOVL that is also part of our stack. And we have been building libraries and tools to build custom spatial data scientist applications. One of them is Airship. It is a UI components library that we also released last year. And when we wanted to think what to use for the legends of our maps and for the widgets that we are going to use, we thought that the best solution was to use Airship, because at the end, the great thing of combining our own tools is that we have full control over them, and we can build them to make it easier to interact between each other. So we are going to see how to build an example like this one. As you can see, there are only a few lines of code, and the main goal, as I said, is to allow the data scientist to focus on the data and not on the visualization itself. So you can create visualizations that have sense, that are beautiful, but in case that you don't want to do it by default, you can also customize it, because we also have this flexibility. So we have been already seeing this so far. We've seen that CARTOframes is a Python package that we are going to use in our Jupyter Notebooks that is built for data scientists, and that we integrated with CARTOVL and Airship and other tools from our own stack. And we are going to do so. We are going to do this in 7 steps. This is because this talk was meant to be a workshop, and we thought that the best way to do it is to allow you to later on see the slides and learn step by step how to build one of these visualizations. So the first thing that we need to do is to authenticate with our account to CARTO. In this case, we are going to use the context. There are 2 ways to set the context. The first one is by the setDefaultContext function that lives in the auth namespace. And you have to pass the base URL and the API key of your account. In case you want to use a public dataset, then you can just write default public, and you can just use it. This function is going to tell CARTOframes that you are always going to be getting data from this context. But you can also create a context. You can instantiate a context by using the context class and just pass it directly to a layer. Why is this? Because what we can do here is imagine that I don't know where I am. Okay. So imagine that, for instance, you don't want to set the same context for all the layers where you are going to be working at. Imagine that you want to add 2 layers, and these layers, the data for these layers is stored in different accounts. So you can, for example, create 2 different contexts and pass each context for each one of the layers. But you can also do it for the sources that you are going to use for your layer. We are going to talk more about the sources after this one. So it is pretty flexible. And now let's see how create the very basic visualization that it's made of a map and a layer. The only thing that you need to do is set the context and just instantiate the layer with the name of the dataset that you want to use. But imagine that you want to start adding some style. In this case, you can use explicitly the style class, for example. So in this case, we are saying that the features that we want to do the features with the color turquoise. But this is very verbose, so you can just write the name of the dataset as the first parameter and then set the style as the second parameter, because what CARTOframe is doing is to cast it automatically to a source and to a style respectively. And now we also allow you to change the basemap. By default, we are using a dark matter basemap because this is one of the, it is the one that fits with more number of visualizations, but you can also set your own basemaps. We have, by default, dark matter, positron, and Voyager, but you can also set the URL of your basemap. And now, let's see how to change the viewport. By default, when you instantiate a map, what CARTOframe does is to set the viewport where the data is. But if you want to change this, you can set the viewport manually. If you're just created your map and you want to see what's the final viewport coordinates and zoom that you want to use, what you can do is to set show info to true. So this, as you can see in the bottom left of the map, you can have the coordinates and you can just copy-paste them and add it to your map. You can also set the pitch and viewing parameters. And in case that instead of the zoom and the coordinates, you want to set the bounce, you can also do it by using the bounce object. OK. Perfect. So we've already talked about sources, but what sources are? We have three different types of sources right now. The first one is the dataset, which is the table that we have stored in our account. We only need to set the name of the dataset that we are going to use. But if we want to apply a query to this dataset, then we can, what we're going to do is to have an SQL query source. But now imagine that you have a GeoJSON stored in a file, and you want to load it. We also allow that, but for that you have to set the path of your file and also the extension, in this case GeoJSON, because what CARTOframe is doing when you're passing a string to the source is detecting which kind of source it is, so you don't have to deal with that. But this is not the only way you have to load a JSON. You can also do it by using a dictionary. You can use actually not only the entire JSON, but you can also just pass features or an array of features and just pass it directly to the layer. But you can also use a GeoDataFrame. So for example, if you use the GeoPandas package, you can just download a GeoJSON file from anywhere, and then convert it to a file and pass it again to the layer. And this is very powerful because you don't really need to have, in this case, an account to load your GeoJSON. You can start trying it right now. So if you start using CARTOframes, you can load any GeoJSON and start using it. Of course, you don't have all the things that you can do with if you're interacting directly with a dataset, but I think it is a very good entry point for those who want to start playing around with CARTOframes. OK, so now that we've seen how to load the source, let's style our visualization. For this, CARTOVL allows us to, through what we call the vis string, to style our visualization, as we can see right now, by just using a simple string. So in this case, we are setting the color of the features to black, the width is to 5, the stroke color is turquoise, and the stroke width is to 1. And we've only needed to do it in a very simple string. But you can also use the color palettes that we have in CARTO, which are also called CARTO color palettes. So depending on the type of the data that you want to show, depending if it's categorical or numerical, you can choose the color palette that fits better with your data. And we also allow you to use default symbols that we have in CARTOVL. So by just writing a symbol marker, then you can see that all our features are now icons. And you can actually use not only the default symbols that we have, but you can use any symbol as long as it is an image. It is true that it may seem a bit out of the scope of this, so what I'm going to do here is to leave you the links for the guides and the reference and the examples that we have of CARTOVL, and you can actually, if you want to try any one of the styles that we have in our examples, since they are all using the same way to draw the visualizations, you can just only copy this string, the style, and paste it here in your notebooks and start trying it. And since our purpose was to avoid data scientists to struggle with context switching, it's very common when we are using iframes here in our notebooks, or at the end, any library that implies using JavaScript in our browser, that maybe there's an error that we don't know where it comes from, so we have to open the console and try to figure out what is happening. What we are doing here is to in order to avoid that, we are displaying very descriptive errors for these cases. So here we clearly see that the size column that we wanted to use for the width doesn't exist. And this is very, very helpful. Now let's say that I want to add pop-ups to my map. I want to add some interactivity. What we're doing here is that we allow you to add pop-ups for two different kind of events, hover and click. So the first option is to pass it directly as a dictionary as the third parameter of your layer. So for each event, you have to say which column or which columns you want the pop-up to show. You can have both events active. And imagine that you just don't want to set the style and just leave the default style. So you can, in this case, assign it to the pop-up. But now, well, by default, what is shown in the pop-up as the title of the value that you're going to see is the name of the column that you've chosen. We allow you to override it by using title values. And OK, so now that we know how to create pop-ups and the style of visualizations, we want to add some legends that, as I said before, are built with Airship. We can do it, first of all, by default, by using default legend to true. So it's going to add automatically a legend to our map. And right now, we have two types of two types of legends, color legends and size legends, and they're more common. So the color legends are, first one, the color category legends. There's a color category legend for each type of geometry. In this case, we are saying that the type of the legend that we want to use is a color category that the property that we are going to be using to get the color is right now the color, and that the title that I want to use is the population, and it automatically adds this legend. Why are we doing so? Because right now you can specify that the type of the legend that you want to add is color category point. So what's the difference between this one and this one? The only difference is that with this one, you can see on a first sight the type of the geometry of the legend that you want to add. That's all. It's a kind of a syntax sugar that we've added here. So in this case, instead of using the color property, we are going to color by the stroke color property, and we are also not only going to add a title, but also a description, and we can see how the legend matches the style that we are applying to to the features. For lines, it works similar. As I said, you don't need to write color category line, but you could if you want to say it more explicitly. And here, the same with polygons. In this case, what we are going to see is small squares in our legends. Color bins for point and line are mainly the same as color category legends. But as I said, in this way, they are more explicit. But for polygons, what we see here is that we can see the buckets of the colors that we are using for each polygon instead of the simple square. For the color continuous for point and line, it's again the same. Oops, sorry. But, okay, never mind. Well, but for the color continuous, what you can see is a gradient when you can see how the color changes between the geometries. For the size bins, in this case, for size, we only have for the type of geometry for the point. So in this case, we are seeing how the size of the points increases, and in this case, we said in this way. So it is pretty simple to add a legend, but I know that the styles that you've seen before seem maybe a bit complicated, and you don't want to start learning how to do this kind of visualizations at this point. You only want to represent your data. So for this, we have built a set of built-in helpers, and actually we are building many more that are just default methods that allows us to do what we've seen before, but also adding pop-ups by default, adding the legends by default, styling your visualization by default. And in case that you don't want to, that you want more flexibility with your helpers, it is also customizable. So the first one that we have is the color category layer that works with point, line, and polygon. And if you remember the style that we've seen before, it was way longer compared with this one. So in this case, we're saying that we want to see from the dataset serial collisions, from the column road count, we want to add a legend that is titled as accident road conditions, and it automatically generates the layer. Same here for the line, and I'm going to do an example of each geometry of each legend because it works in the same way. But it's great to see the differences between the geometries and how we are generating the legends. And in this case, this is the gradient I was talking about before. So for the color continuous layer, in this case, this is how the legend is generated. As I said before, it automatically adds the pop-ups for your visualization, but you can override it. So imagine that you don't want to use one of the default palettes that we have for you, and you want to use specific colors. Then you can do it. You can change the title, the description, and in this case, the number of bins that you want to represent. And let's see how all of this will work together in a normal workflow. First of all, what I want to do is to set the context. I'm also going to import pandas since I'm going to be working a bit with data. I'm going to set here, okay, I didn't leave here my AP key. I thought I did, but I didn't. And so in this case, what we are going to do is to visualize the bike stations that are available in New York City. So first of all, what we're going to do is to get 2 different data sets from different URLs with pandas. Then what I'm going to do is to convert it to DataFrames, and then I'm going to merge them in a single variable. And after that, what I'm going to do is to visualize the table as I would normally do. And now what I want to do is to upload this data set automatically to CARTO, so I don't need to leave the context for that. I have to specify which are the coordinates that I want to use. In this case, are long and lat. And after that, I only need to, in this case, use the color beans layer helper method and set it there. So as you can see, this is something that is going to help us a lot to create awesome visualizations without leaving the context of our Jupyter Notebooks. We are going to add more helper methods. We're going to add cluster legends and many more things. We are also going to add widgets, for example, widget that allows you to interact with animations. What we are going to do is to allow more functionality for data scientists to interact with CARTO for data manipulation. And we are also working so hard to allow you to instantly share your visualizations from your notebook. So you will be able to generate a URL and then you just have to share it. Okay, so thank you very much.
Thank you, Elena.